we discussed with more things about more things or simple model of electromagnetic, electro and then magnetic. Is it right? And now we got to see about the units representation of these both quantity. And how do I say? And for this, especially for electrons and especially for the magnet, and you represent in the form of height. Okay. So each and every time they used to go with the unit form. For both things, that means for electric as well as that of a magnetic. What I do, I just go with a small table form, okay, table structure. And what I do, please have a small table over here. And do some more table, and then what I just go with means, and first one, I go with this electric. And usually, why go with electricity means the source is from the sun, is it right? The sun is giving the more electricity, is it right? That's why I go with electricity. Okay, no more comments going. Next, I go with the over 9 planets action. All the 9 planets will be the magnets, and that's why I go with the magnet. Okay, to field as well as a magnetic field. Okay, and now I go with the field quantity. So what I do, I go with the field quantity. What's the field quantity means? Two things are available: electric field intensity and electric flux density. So field intensity represents, put it over here. This is a mobile phone, is it right? So in this mobile phone, this is getting a signal from nearby more base station. Base station represents the form of a mobile phone tower, is it right? That's called a base station. So in the surrounding base station, which base station which gives more intensity, that's called what? Idea, because it's carrying the Idea mobile phone cellular service provider. So that Idea can able to give the good intensity with respect to the battery, okay, because based on the battery, it is receiving the power, and that power delivered to the main core processor, because that is not discussed over here. This is a different subject, and then from there, it's going to get connected to the network. Is it right? So that is why I just go with the field intensity, because in the field, I have more things, because nowadays, you know, the network, that means BSNL, Airtel, and then Idea, and then more things about this, right? So which one that, because this is said to be a magnet, okay? Mobile phones will be a magnet. Inside that, there'll be a source of electricity, that's called what? A battery. So which should be connected to the magnet, because all the radiation from the mobile phone towers are said to be the magnetic field. So this electricity is right now in the particular field, and what's the intensity? Intensity represents which signal it wants. That's called what? Electric field intensity. The first one is said to be electric field intensity. Just rub over here because I want to write somewhat down, because it should have more space. And afterwards, I'm going to electric flux density. Let's look at over here. The same electric, but here I want to use the flux density. Electric flux density represents, because in one area we got a more number of mobile phones. So all the mobile phones is receiving more signals, and one mobile phone is giving a more signal strength. Another mobile phone is not receiving any more signal strength. Likewise, there'll be more competition. That's called what? Representation of this electric field intensity. Okay, and that's right. And now I gotta go with the next one, magnetic. I'll go with the magnetic. In the magnetic also, the two things are available. So what are the two things represents? Magnetic field density as well as that of magnetic flux density. The both things should be available. So now what I just represent with the both things. And now I go with the, because it is always here. So after this, you make a small separation. And now I go with the magnetic. I go with the magnetic field intensity. Magnetic field intensity are the same. Here I just written electric flux density, right? And now here I replace the electric by a magnet, okay? So here, magnetic flux density. So look at over here, electricity means what? We got electric density means, I guess you use the mobile phones, right? So magnetic field intensity means more number of mobile phone towers available. And how many number of mobile phone towers among that, which one receiving more signals from the satellite or from the source? The same case, magnetic flux density. So among everyone, which one is giving the service, giving the signals to the very long extent? That's also different, okay? And now I go with the specular parameter. So electric field intensity is given by E, okay, and electric flux density is given by D. Do you understand, please? Right, E as well as that of D. So field density is E and flux density is D, okay. And now I go with the magnetic. So magnetic field intensity is gonna be B. Okay, over here, these things you should know about this one, okay. Magnetic field intensity is gonna be B, and magnetic flux density is gonna be the H. So these are the main units that is to be represented, okay. And now for this one, these are parameters, and I want to go with the units, right? Because for each and every parameter there should be a unit representation available, is it right? And who are the unit means? First one, electricity, is it right? Now I go with a small column here. Whenever there comes electricity, there should be a what? Voltage, is it right? So for particular meter, because electricity can't be the action for long meters. When I pass electricity, there should be electric field for some extent, is it right? So you take the form of a meter. For 1 meter, how much electric field intensity or how much power of the electricity is available, and for 2 meters, and for meters. Likewise, you measure the electricity in the form of a meters. Okay, so electricity measured in the form of a voltage for 1 meter. How much things? Okay, and next one, flux density, and it's mainly for this flux density represented with the form of a charge. So C per centimeter square for per area. In this area, how much charge it can able to take off? How much charge? That's right. Okay. And now we go with the magnetic field intensity. Okay. And for this, you can just represent the form of a T Tesla. The simple one. Okay. We won't talk about. And next one, H. Magnetic flux density is mainly a representation of driving of the current. I. Is it right? So when I go for driving of current, there will be a more number of electrons to be produced, and the more number of electrons to be go over the long extent, and that is going to be ampere per meter. So previously got a voltage, that's for electricity, and for magneticity is going for ampere. Okay, you know, is it right? So you know the Ohm's law, and V for electricity and I for magnetic field. Okay, so A per M. Okay, V for intensity and I for flux density. So this is about the main thing of any units with respect to electric and magnet. Okay, we'll see you next class. Thank you very much.